Is this working? I think it's working. Is anyone here? Ah! All right, we got any people in here? If there are any topics that we want to discuss, or that you would to discuss, then make it known. I will go for any topic people want. Top of today's lesson. This can include non-Farsi modeling, other parts. Ta-da. Okay, so who do we got? I'm gonna wait a moment. I'm gonna give it I'm gonna give it 10 minutes and then we'll start, just to get everybody in here. So skip ahead a little bit if you're watching the review after. There's a camera. Bones in my skin. We'll start in about 5 minutes. Start at 2:20 EST. The real reason we're starting at 2:20 is because I want a lollipop. I want a lollipop, and there's not one. I'm a little sad. I deserve a lollipop, at the very least. I think I've earned one lollipop. Okay, we start in like a minute. Testing, 1, 2. Testing, testing. Okay, significantly quieter. All right, 2:20. The clock has struck. It's a 10-minute clock. It goes 10 minutes. Anyway, we'll go ahead and begin. So today we are going to go over the pipeline for robot prototyping. Kind of go over the method for taking a game piece and being like, okay, how am I gonna move this? Taking where you have to put it and be like, okay, how am I gonna move this from, you know, wherever I'm grabbing it to wherever I'm putting it? You know, how am I gonna design my robot chassis? How am I gonna make these parts fit? Well, et cetera, et cetera. And that the best way to start with it, most people will find when they begin modeling, is to start with a 2D sketch and then move on from there. So we're gonna go ahead and create us a new document. If you can follow along with this, that'd be great. In Onshape, this is quite an important lesson when it comes to robot design, robot prototyping. Just CAD in general. This is kind of this will be the bread and butter of the episodes. When I come back in July, I will be discussing this almost primarily. Is just different methods of designing a robot. So we'll start with our 2D sketch. As an example, I think one of the ball games are pretty easy because you know, there's not really a way you can grab a ball that's going to mess up. You don't have any lopside. You don't have a tipped over cone. You don't have a, you know, deflated cube. You might have a deflated ball, but generally you have about an inch or 2 inches of compression. So generally ball games are the easiest in terms of intaking because you can just use a couple rubber wheels. You can use a pneumatic clasp. You can use whatever. They're very free in terms of design. Fairly easy. Now for Manual 20, we're going to go to 2020, the year everybody really liked because Championships 2020 was just amazing. Okay, anyway. Okay, no, we're going to go 2021. I was wrong. Game. Those years are just so blurred together for me. Probably for a lot of other people too. Is this right? Is this the... We're looking for, it's like a big tennis ball, right? All right, I don't care about sponsorships. This is not it. Is it 2023 right now? It's 2023 right now. A little bit out. What do we... Yeah, it's 2023 right now. Okay, we got, I'm gonna go through here, down a bit. Who is this? Woody. It's Woody Flowers. Everybody's favorite lad. This is the game manual. We're looking for game pieces. I might as well use the table of contents. Cargo. Okay, so it is a 9.5 inch. Yep, 9.5 inch. So we'll create a sketch right here. Say, okay, our ball this year. We'll just create it up to the side. Don't make anything 9.5 inches. So this is our ball. Go ahead and hide the planes. It's our ball this year. So we want to create a robot to intake it. I might be like, okay, I'm going to have my chassis. Maybe you've already designed your chassis and you're like very stubborn about using it. So let's say I have a 32 by 2 inch chassis. All right, this is going to be my robot. You know, maybe we're using swerve modules. There's a constraint here that I don't like. Okay. So okay, this will be my robot, right? Maybe I'll put a few wheels down. Say like, okay. Just as an example, because it has to be lifted off the ground by a certain amount. I want these to be equal. Okay, I want the distance between this to be 2 inches. Distance between 2 inches. There we go. Okay. So, that's our profile. I think sort module will stick down a little lower. We're just using this as reference. So let's say this is, this. So I need to grab this ball, and I could say, okay, my goal is, let's see. Goal is 4 feet wide, so I can go ahead and prototype that. I can say, okay, here's my 4 feet goal. Now, cool thing about Onshape is you can actually just, any CAD really. This is an exclusive. I can just take this file, a Parasolid file, and put it in here and just have the goal. So I can design just a simple robot and then put it with the field to test it. So I might say okay, this is my goal. It's 4 feet, 5 inches. What did I say? 4 feet plus inches. So, and then it goes kind of, I don't know, trapezoid. It's just the top that matters. The sides don't retain much value. Make these equal. So this is kind of the goal that I've got to get it up to. If you're going for the lower goal, good for you. We're doing we're learning professional CAD though. We're doing the high goal because we're super good. We're learning good CAD. You know what I'm saying? Now the lower goal may have, and I'm just skimming over it for now. But the lower goal, there is I don't know if it shows it. I'm gonna go back up. There's a lower goal below this one here where you can drop in the we can drop in the game piece cargo, it's down here in reference. But if you're able to cycle that really fast, it might be better than shooting high up. But shooting high up is more mechanically complex, so we'll go for that right now. But say, okay, I need to intake this, right? And then I need to get it up there, right? It is how many inches off the ground? I need a Spark Notes version of this on B-Roll. You got any questions yet? No questions. Cool. Okay, I'm going to go ahead and say it's up here. There we go. Here it is. I don't want to watch the YouTube video. So you've got your, lower goal, upper goal, whatever. Okay, there we go. 8 feet 8 inches off the ground. So we'll say this is the ground. We'll put the dimension from here to here. 8 feet plus 8 inches. Ta-da! So that's kind of our goal. That's what we're going for, is up there. Now, already this has some use to programmers. Just modeling out, because I could say, okay, I'm going to need a limelight that is going to be positioned at this. If I say, okay, well, our limelight's going to be positioned at 60 degrees, go ahead and account for that in programming. Make sure that you're able to do that, right? Go ahead and put that on a piece of a board and test that. That's kind of useful to programmers, just having just any information earlier. At the very least, they're going to go and update all their libraries and make sure that everything's working well. Even if you don't know anything about programming, it could still, if you can just talk to your programmers, be like, hey, this is going to be, whatever. 30 inches off the ground. And if you are the programmer and CAD person, then good for you. Oh, I messed up. We're going to leave the robot there. That's where we're going to be shooting from. But I can say, okay, this is kind of the bread and butter right here, is how am I going to intake this, right? How am I going to grab this? So I could say, all right, I want wheels, right? I want compression wheels that are 2 inches, and I want it to push against the ball. I want a wheel right there. When I go up there, I want it to push through, and I'm gonna say, okay, I'm gonna push it through right there, right? It's gonna grab it. So I'm gonna have to put a wheel now that's gonna spin up. If I put a wheel back here, it would grab it when it's here, but it's not really going to grab it when it's down here. So down here, I'd have to have like another wheel, maybe. Another 2-inch wheel. And I can say, okay, when I roll up to it, it's gonna push it down a bit and push it into here, and then that pushes into there, right? And then that's gonna keep going, and then maybe my shooter mechanism is back here. I could say, okay, I've got my, now I'm gonna have like a belt right here, right? And this is, I'm just hammering this out, and, you create a simple design and then you have people review it. That's kind of the whole thing with prototyping. You just have people review it. Maybe I'm going to have a belt right here, right? This will be a belt. Like I said, this doesn't, you're just kind of prototyping. So somebody can say, oh, okay, if you put your belt there, there's going to be a skip right there. Oh, that's not so good. You might want to put like a piece of bar over here to prevent it from, going up or, whatever. So you say, okay, it goes over here. Now I want my like shooter mechanism to have like, a couple wheels that push it up, maybe 4-inch wheels. I want to have like a wheel that pushes up a little more, 4-inch wheel. Is that connected? I think this might be connected. I need to disconnect that. So, okay, now I've got another 4-inch wheel. So I can grab that, Control C, Control V. Moving around a bit. Say, okay, I got my wheel there. That's going to push that up, and then I'm going to have like, I don't know, my shooter mechanism right here. That's going to have a big wheel, 6-inch wheel that spins super fast, pushed by a, 2-inch wheel. And then I can just say, okay, here's my design. I can drag it through and say, okay, this is going to kind of be how my parts are laid out. And I'm going to say, okay, push. It'll push through there. It'll hit that and then roll onto that belt. It might skip up over there. We'll need a little framing right there to make sure it doesn't skip out. Maybe a wheel instead or something. I don't know. It doesn't, just a little thing. But it's going to push down there. I don't think that, and you can say, okay, I don't think that it's really going to fit, through that slot. So we're going to put these two wheels closer to each other. Now it maybe will squeeze through there. I've got a bit of compression. And then I might need another wheel right here. Keep it in. It'll push it up. I don't think that'll quite fit. Move this wheel over this here. And this is just, kind of the simple design process for just a rough prototype. This isn't like trying to measure something out. This is kind of see just kind of how your thing is going to work. So these wheels push into there. Okay, now that's going to fire, right? And it's going to fire up into there. So, that's kind of thing. You'd be like, oh, this design looks kind of dumb. It's weird. You just kind of spaghettied it together. Well, I'll show you our 2019 robot, or 2022 robot, 2022 robot design. This is, I think I might have, did I make this? I have no idea if I made this or not. Made a few parts. I don't think I made this. I made a couple of parts of this robot. I came up with like the 2D sketch for this year. Kind of said, okay, I'm gonna have, it's gonna be weighted in the back, and we're gonna have an intake in the front. And one of the things we were discussing is if we have an intake in the back as well, we'd have dual intake. We'd swerve, so we didn't really care. But this might be something. I'm looking for a 2D sketch that we had come up with. Is this just a square? Is this literally just a square? I think this is literally just a square. Go back. Maybe I can find the 2D sketch. No, I don't think so. But you can see we went through a lot of different iterations as I was scrolling through there. And this robot is more, this is, we made it to Worlds with this robot. It was our first ever Worlds that we went to. And we had, I think like the second or third fastest robot on the field because it was so light. We had an extraordinarily light robot. It was very agile and swift. And this is basically just the same thing. We just flipped that, actually. Whee! Okay, now it's flipped. You can hit this cube. If you hit the corner of the side of the cube, it'll flip it for you. Pretty convenient. But this is more or less what that is. Is you've just got your two wheels right here that will push it. Now it pushes against the bumper as opposed to thing. So this ball comes up in here, and then it just kind of pushes up against the bumper, right? And then it rolls on a track, pushes through. And then what we did for this instead is said, okay, we're going to have our, it fires this way instead of that way. So we said, okay, I've got this. I want it to fire. Instead of spinning around and going the other way, we're just going to have it fire backwards, right? So this was our, like, you know, power. And then we put we put this on like a mechanism so that we could turn it. So this right here can like turn, and that'll determine our firing angle. So what we just kind of said was, okay, I'd like to get rid of that, was it's going to fire this way, right? So I can take this, Control C, Control V, scale it to -1. No, that was wrong. 0. -1. Can I scale this? Okay, what we're gonna do instead of that is we're just gonna mirror this right here. Put a vertical line here. Mirror. Mirror line. We'll mirror all these parts here. Cool. Now I can take all that, delete it, take all this, Control C, copy, delete, Control V. And now I can say, okay, if my wall was intaked right here. Oh, no. This is 9.5 inches. This is intake right here, you know, and I can just kind of drag it through and say, oh, hit that. And then I can say, like, okay, if we're standing in CAD, I can say, okay, if we're standing, you know, select this point right here, or select the middle right here, and then, you know, actually what I can do is make a point. I'll just make a point real quick right here. Boom, point in the middle. Looks like this point. And this point right here. Say, okay, our firing angle is, we're firing 133 inches away, but it's going 109 inches out and 75 inches up. So then I can say, okay, if I created an arc between, you know, here and here, and I don't even have to do any math for this, I can just kind of create an arc of how I want it to fire. So, you know, I might say, okay, I want it to arc up like that into there. So I'm going to need to make this, I can already see that's not going to work. I need to make this like significantly lower and the fire significantly higher for it to be able to do that. You know, or I could say, oh, I need this to fire like, oh, I messed up. Delete this and create a spline instead of kind of what I'm trying to go for. Just, okay, maybe the ball will go up here like that. And then I could, you know, make this into geometry and then calculate it from there. We might go over the math bits go over some things like FRC calculator, different ways to calculate your tolerances and things like that. We'll go over that much later. That comes kind of later. Do we have any questions yet? Any people curious about anything? No. So just from this prototype, I can kind of get a rough idea of what we want the robot to be. You know, I could say, oh, get rid of those constraints. That's a bit bad. Okay, we'll just accidentally connected these two things. That's not so good. Get rid of that. Now I should be able to move it. Yeah, there we go. So now I can say like, okay, we're gonna intake it here. Boom, bump, and then it's going to go in there. And that just kind of I've already got kind of a rough idea of how I'm going to go. And like I said, this is the design process that we used for 2022, and we ended up having a really good robot. Like our robot formed, like we were going toe to toe with some bigger teams like Orbit and Mad Town. I don't know if they were on our field. We were on the Carver field that year. We're going not toe to toe, but we were performing really well even against them. We're having some really good games. This robot did well. It's nothing to scoff at, even though it was in a lot of our younger years. It performed quite well, and just out of this design process alone. And now we have a far better design process for things. What we do is we have the reason I'm doing these classes is because when I do these classes, now that people who are going into on-season know how to do CAD, what I can do is have each of those people make prototypes for different parts and have them and force them to create different ideas. I can say, don't create an idea that's similar to other people, and all of them create different ideas. And then we weigh that and just like kind of review it and like, okay, would this work well? Would this work well? Would this work better than this? And we can stick all of these different ideas kind of together on a robot and say, okay, what's going to work the best together? How can we make these mesh together? And now it's a really rigorous design process that allows us to succeed and allowed us to do really well this year. Frankly, our intake went through like 18 different redesigns. Our main arm went through like 4 major redesigns. In terms of like adjusting parts and swapping out parts. 6 if you include swapping out gearboxes and things like that and changing how those worked out. So we had a pretty rigorous design year this year, and it's all because we were just able to prototype stuff on Onshape and hammer it out really quickly. One of the nice things about Onshape is we can put all the prototypes in the same document. As much as Fusion or 3D Experience might try and, advertise their collaborativeness, there is really nothing that compares to the collaborative power of Onshape, even though its modeling abilities may be a bit lower, not quite as good. Onshape is inferior to SolidWorks in terms of its rendering capabilities, or its not its render capabilities, its CAM capabilities, or its making surface modeling and things like that. But yeah, where it really shines is ability for just everyone to work on the same document. I mean, 2 people can literally, although it's a bit buggy in its current state, it doesn't work perfectly. You'll have a few errors here. Nothing's going to break your file. You'll never have a broken file from errors. Never in my life with Onshape. I've been using it for like 3 years now. Never have we had a broken file because of Onshape. Never have we had to like go back to a previous version because 2 people can work on the same document. Maybe, the only bugs that we've had so far is like it not updating instantly. I might have to hit the check mark for it. Like if I'm in the sketch and another person's in the sketch, I might have to hit my check mark for it to update. And that's all that we've had. So everybody can have just the same document. They can be working on it. They can all have the different prototypes. I can go to an assembly and take everybody's different prototypes and insert them and stick them in together. And, insert whatever 2D sketch I have and take a part that, Bryant made, or a part that, Chelsea or whoever made or whatever, and just put it all together. And just see where it works, see what looks really nice, calculate tolerances, all kinds of stuff. Now we'll go into a bit of 3D prototyping. So let's say that we've got this kind of 2D sketch. This is based on a team, I forgot their number, but they're from Chesney, South Carolina, I think is the name. Slybots, I believe is their name. They came and they were wondering how to do CAD, and I came up with we worked with them. They had a sketch on paper that they showed me, and I put that into CAD and then animated it so that they could see that it would actually work pretty well. So what they had is I'll go ahead and show you what they had on paper. They had something, they were like, okay, we want a robot that's kind of like this. We want a robot that's like, weep, and then we want like an arm to go down, right? And grab it. And then they just had this like rough sketch on paper. And I want this to move up and be able to like lift the arm up. And so they just showed me this and was like, how would we go about doing this? And I was like, okay, well, so I can, make your chassis and say, all right, you're going to have an arm, right, that comes up, make this construction. So how tall is 2023? Look at 2023. This is just the year. We want to look at 2020. 2023 game manual. Oh, I didn't even look up robotics and it just came up. How nice. Thank you, Google. 2023 game manual. Going. Cube. Okay, I want to pick up a 9.5 inch cube. Wow, everything's 9.5 inches. FRC needs to start changing some things. I need to do like another disc game or something. So this is my cube. 9.5 inches. 9.5. 9.5. And then I'll fill with the corners to kind of simulate what I've got going on here. I'll fill with these just a tad bit. Pull it in a whole bunch. Honestly, that kind of looks like the cube. I'm going to be real. We'll fill with that a whole bunch. Okay, so now I've kind of got my cube. It's not exact. I could import this into CAD. In fact, I could go over here in my assembly and just put in the cube if I wanted to go to MKCAD. My favorites. Cube. I can just put in the cube like straight up. And this is imported from SolidWorks. Like this is a SolidWorks part, but it just works in here perfectly fine. I've got the cube. I mean, that's our cube right there. But what I can do is say, let me erase this. This is kind of getting in the way. Kind of a neater version over here. We want it to be. This is kind of what they're going for, right? So already I can say, okay, you can make this with like tube or something. So we'll go center point rectangle. So we'll make this 2 inches. And we'll make this like, we'll start with 18, but we might change it later. So I can say, okay, to get a, let's say I have a bar, I can't have it stick out my chassis. So I'm going to go ahead and just say like, okay, this is going to be a hex shaft bearing, 1 inch. And then I'm going to have a bar. This is a situation where I'd use the aligned rectangle. So I'd have it come out just a little bit. So I could go like that. And I could do it the other way. Actually, what I could do is mirror this. No, we'll go ahead and make this one. We'll make this another 1 inch bar. This should be 2 inches. Yeah, so another 2 inch bar. We will mirror this as well. Now what we'll do is we'll just have this stick out. Go ahead and clean that up. Hit that eye coincident. These two need to be perpendicular. This needs to be 1 inch. Make these two perpendicular. Ta-da. Okay. So that's my bar sticking out. I'll make that a bit longer. So now I've got my intake here. Let's see. I've got like an intake kind of like ours. It's going to have... It's going to just have like wheels right here. They're going to rest. Maybe there's a hole in the middle of the chassis, you know, that lets it sit on there so it can go down just a little bit farther. Just say, okay, I've got this. Now, what I could be able to do is, if I were to extrude some of this as bars, I could say like, okay, I'm going to have that be a bar. And then I'm going to have this be a bar. I'm not going to include that hole in the center there. That's going to be X shaft. This is going to be another bar. It's a new part. This is going to be another bar. Select all the parts. Don't select the hex shaft. Extrude this. It'll be another bar. New part. Now these are starting to intersect. That's fine. Go into our sketch again. Now we'll have a cylinder that will extrude. Make it just nice and big. This is just there as a reference. So then I've got my intake. We won't do, yeah, we'll do that actually. So we'll extrude that and attach it to that part right there. Okay, so now I could say, actually, we're not going to do that. We're going to make that a new part. So now I could go ahead and put this in an assembly. Now I know this all looks really kind of roughly put together, but you'll see it come together in a moment. So we'll put 2 of those in, right? I can say, I'm going to fix this. Fix. And then I want this to be fixed as well, actually. Now we'll still keep it 2D, but we're gonna, now everything that I'm doing right now, you could still do in a 2D sketch, but you'd have to mate it up. I find it easier just to go ahead and put it in assembly and see it. So we'll do a cylinder, we'll do a revolute mate. We'll say middle of this right here. And then this point right here. We're gonna revolve around each other. And then we're gonna have revolute mate here, just as a representative. So now what I can do is say, okay, I've got this right here. Now how high is my chart station? So I have to put this, say I want to hit mid goal, right? That's 1 feet 10 inches off the ground, roughly. Right. One feet 10 inches off the ground. And you get a 1 feet 10 inches off the ground. And that is, if I go into a sketch, I'll go front, and I'll just make a new sketch right here. And say, okay. It's like, how many inches out? It doesn't really give me that distance, does it? I don't know how many inches it out. But I can still import the, you know what? Watch this. I'm going to show you a magic trick. Go to game pieces. We're in assembly. Game elements. You can just import the, should be able to. That's the substation. There's the grid. And just insert the entire grid. Isn't that cool? Just wait a bit. Boom. The entire grid is now here. So I can move this over to the robot. mean, that was pretty fast loading. I'll be real. That was like 10 seconds and it was in there. So we'll go ahead and move this over here. Bump our robot right up against it. And we'll say, okay, if I wanted to hit mid, right, I'd have to have a robot with a chassis less than 18 inches wide, and then I'd be able to slide in here. I'm going to move this as just an example. We're going to slide our robot in there. Actually, no. I want it to be about 12 inches. 20 inches. I'm moving the substation around the robot right now, as opposed to the other way around. They're like 4 inches. No, -4. Okay, our robot bumps up against that. And as we're bumping up against that, I'm going to rotate this up. Okay, so now you can say, okay, this if I had this as like a 4-bar right now, rotate this up, cube would totally spit out up there, right? So I've kind of done a combination of a 2D and a 3D sketch. Now what I can do is make this as a real 3D part. So I can say, okay, I'm going to have my chassis, right? And then I'm going to have like maybe 2 bars coming to the middle. You know what? I'm going to have 1 bar coming up in the middle, right? And then I'm going to have 2 bars attached to the side. Now this is a horrible drawing, but you'll kind of see what I'm going on about in a moment. So now I can say, all right, I've got my chassis. We're going to we're going to make us a chassis. So Part Studio. We'll go ahead and get rid of these parts here. So now we can do a real 3D part, right? Now that we've kind of gone through the phases of prototyping. Oh, you can say, okay, now this whole thing has taken me in total about like 20 minutes, 30 minutes a day, right? This whole process, right? If you wanted to create an actual robot prototype, that would take you a long time, just to say the least. That would be a while that you'd have to be making an actual robot when you could just be making a prototype instead. So we'll have a 18-inch chassis. We'll do an eSpots chassis or something. 22. So they have a really small chassis. Super fast robot. Their robot shoo across the field. Super fast. And then I'll offset that by 1 inch. Enter. Type 1. Boom. Then I've got a 1 inch chassis. We'll make it at a 2-inch bar, and then we'll cut the corners and weld it. That's what we'll do. So the corner here, we'll weld it, or we could just not have corners. What we could do is just have the bar, and then attach it via swerve modules or corner brackets or something like that, or bumpers. I don't know. We don't have to have that diagonal corner. What we'll do instead is just and then I could say, okay, I've got this is my chassis. I'm gonna go ahead and import it. Go ahead and rename this to chassis. That is not a chassis. Okay. And now, with the magic of hiding this, go ahead and import me some swerve modules. Now I could make an assembly for the. What you should do is have an assembly for the robot, and then have an assembly to put it on a piece, right? You don't want to combine those. We will do our Mark IV iceberg modules with a Neo and a Falcon. Steering motor, Neo. Yep, there we go. Insert.
This is a test of the Oxapomo Community College Emergency Alert System. This will be followed by a text alert. In addition, there will be an activation of the outdoor warning system in the state.
Alright, we're about to have an air raid siren go off because of testing, so you'll have to bear with me on that. It's a test for the college. It's like a emergency test. So if you hear an air raid siren, everything's okay. We got 8 people. Move this down a bit. Actually, what am I doing? I can just make this. We're gonna insert 4 of those. As you can see, we've got a Neo and a Falcon in our little swerve modules. Yeah, there's the air raid sirens. Swerve. So now we're gonna do that 4 times. Insert Mark IV. Swerve module. Neo. Insert. Then we'll do it again. Neo. Insert. Now we'll go ahead and fix all this. Fix. That makes it hold still, basically. Makes it not move or rotate or anything. Just makes it static. So what we'll do is we'll do a fasten on, I don't know. Does that work? Not quite what I was going for. Okay, no, we don't want that. So ideally, I'd probably want to put holes on this and then fasten to that holes. We'll just move it around because I don't want to do that. But what you could do is you create holes in this bar. Rotate that by 90. That's not 90. No, that's 90. There we go. This will take a moment, so just have patience. But optimally what you would do is drill holes, or not drill holes, but make holes into this bar, and then say, okay, I want these holes right here to be attached to these holes right here, and then just fasten that on, just to make sure it works. But this is a prototype. This is for education purposes only. Don't try this at home. I promise you that I'm better at modeling though than what I'm showing, but we're just going over examples here just to make sure that people understand the concepts. Do as I say, not as I do. Everybody's favorite excuse to bad parenting. Ooh. Go down a bit with that. And then we'll make that go down a bit. Okay, so now everything's roughly attached. No, it's not attached at all. It's not even close, but it's on there. That's the point. It's on there. That's all we really need. And today's day and age. Now what we'll do is put this back in. We will rotate this by 90 degrees. Funnier that rotating the whole game piece is faster than rotating the actual object. I don't know where the robot just went. It's in there. Then we'll go to the top plane and just move this around a little bit. Now I just clicked this corner and kind of dragged it over to the front. Okay, so I can now really see that this chassis would not fit on there. I need a chassis that's like 4 inches smaller on the width. It has to be kind of smaller. But I could also just make a longer arm and a bigger robot, so, you know. But eSpots, they made a chassis super small. Their robot could fit in this thing, I think. I'm not so sure. I'm pretty sure it could fit. It was a really small robot. I mean, that thing was zipping across the field at Mach 5. The thing was getting like 5, second airtime. It was just balling, I gotta say. Anyway, now I can import my other parts studio that I made. Say, okay. Insert my bar, and then I'll go down here and insert another one of these beams here. Boom, I'm balling. Now I'll take all of this and rotate it real quick. Okay, now this bar obviously wouldn't fit, but we'll just disregard. We'll disregard that. But now what I can do is, that needs rotated. So okay, and I can just kind of I'm going to use my imagination, guys. We don't need to model everything perfectly when we have the power of imagination. I could just be mating this. So we're going to fix that onto there. Fix that onto there. Nope, don't want to suppress it. Fix that. Now I'm going to do a revolute mate. Attach this onto that. And revolute mate. Gonna attach this onto that. Okay, and then I can say parallel, maybe. Maybe I can parallel these guys. I had a bad mate connector. Alright, we're just gonna hit that right there. Then that right there. That ought to work. I said parallel, shouldn't be put them together. Okay, now let's say my intake. I'm gonna go to the right plane now. So my intake was at like the corner. Let's say that the intake was just fastened on. So we're gonna do we'll see if a parallel mate works. It ought to. Cool. Alright. Again, this is just for example. Doesn't have to be perfect. So now if I rotate this up a bit, Okay, well, it didn't work. But either way, I can demonstrate that with the robot designed with this random stuff. It didn't work. I did the mates wrong. But robot design like this with these two bars were connected to each other. Now I can kind of take this and say, all right, this is what I want my rough sketch to be. Okay. I want to... This is what I want my rough sketch to be. Let me see if I can't orthogonize it. Okay, so now I could say, okay, if these two bars were even, right, for them to be connected. Why not? Just work. So these two are even. I could say, okay, I can either put a chain, you know, right here on either side, or I could have two of these bars, right? I could have a bar like this, bar like that. Then I could run a chain in between it. That's a horrible drawing. If I'm looking at the back of the robot, this robot's caboose, right? You've got your wheels. Now I could have two bars up here. And then a motor right here. And then a hex shaft right here. Maybe I could put another motor on the side. Oh, I wonder what robot this is kind of looking like. And then I could put a chain on a hex shaft right here. Hex shaft bearings. Now I could have a chain right here. And then these two arms would stick out. And now it's no longer the back of the robot. It kind of is amalgamate. Then I'll have maybe two arms that are on this chain. Maybe just one arm on this as this chain. Then this sticks out. Maybe I've got another thing right here. Like that. And then this can have my intake on it. That's a oh my gosh, that was awful. Hold on. Now I can have my intake on it. Right, on this chain. Hopefully you guys kind of get this, what I'm drawing here. Oh, no, the wrong key. I'm going to save that, actually. I like that drawing a lot. Dang it, stupid. But, save. Cool. Sure. But you can kind of get what I'm putting down. We'll go a little bit more over on robot prototyping Monday, but this is a good way to kind of test your ideas at the very least and show their validity, as opposed to just putting it on paper. I can now put it in 3D and make it a lot more tangible. But just from this, I can kind of say, okay, I want two bars here, so I can put a chain in the middle. Or I could say, all right, I want a winch right here, and I want to attach the winch back to this string right here, and it's going to pull this bar up and down. That's what that's going to do. And then I'm going to run a wire up this side, and then I'm going to have my intake right here, be on this like hex shaft right here. Then I'm going to have a motor on the side. It's going to connect in and grab right there, and then it's going to rotate back and forth. If you have the app on your iPad, Procreate, that's a really good prototyping drawing app. I'm using a smart board to do all this, but you know, you do it on paper, it probably works the best. Say, all right, this intake rotates. I'm going to have a wheel right here. We'll roll it to. You know, it's just a good way to solidify your ideas a little better. The more places you put your ideas, the more people can criticize them and review them and help you work with them and teach you and help you learn. The more places you put your ideas, the better. The more systems you have your ideas put in, the better they'll generally work. The more people see it, the more people can comment on it. Even if they're wrong, it still makes you think about that part. Like somebody was like, "Oh, shouldn't we have this robot be a bit wider when we were designing this year's robot?" I was like, I can't really see a reason why. But I should have had more people ask that because we actually needed to fit 2 Hexbore encoders on there that I didn't previously considered. So we had to widen the our arm a little bit to fit those, which was a pretty big redesign. But yeah, I'm gonna let everybody go. If anybody wants me to model anything else or anybody has any questions, you can ask away. Otherwise, I'm gonna go ahead and let everybody go. Concurrent. What's a concurrent viewer? I don't know what it is. I'll sit around for a minute or two, letting everybody answer questions. Or I'll answer other people's questions. I don't think we usually don't have any questions, so. Next, I think, let's see, am I gonna be here Monday? Yeah, I'll be here next week. So I will go over some real. I'll do a like whole actual robot next week. We'll start from prototyping. I'll have a game piece. I'll probably do either a disc or a cube, maybe a ball. No, we'll do disc or cube, and I'll go through a whole prototype just of how I would go about designing a robot for that. So that's what we'll do next week, is go over an entirely just from scratch, making an actual robot, not just some kind of put together robot to demonstrate an idea, but an actual good prototype that we would hypothetically start being able to assemble. So that's what we'll do next week. I'll wait for about 4 minutes till 3:20 for everybody to ask any questions they want. Otherwise, I'm going to let everybody go. I want to listen to my voice a bit in the meantime. I like listening to my voice. Listen to me. Look at me go. Look at me go. Look at me go. I need a lollipop. I'm a big shot. Wow, look at me. Look at me, Ma. I'm teaching. I'm an educator. I'm an educator. Education. Bones inside of my skin. They're crying, trying to get out. Trying to get out. Do 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 do. Come July, now I know that's a long way away, but come July we will be doing CAD-a-thons and a lot of challenges, so look forward to that. It'll be real nice. Next week I'll have a better laid out. It'll be less organic. I'll have more laid out lessons. We will go over very specific. Like I said, we'll go over a whole robot prototyping system. We got 1 more minute if anyone wants to ask any more questions. If anybody has any questions, I'll go ahead and let everybody go. I'll go ahead and end stream at 3:20. All right. Remember, the first step to having a really good robot is designing a really good robot. So I'll let everybody go. Have a good day. Good luck modeling.